Now, feeding billions of people at reasonable cost is a big problem, one might say an industrial scale problem. BAADER is a German company that makes machines that help with this, to process mostly poultry and fish. Patrick Neff is a data scientist there who developed a really cool pipeline to take all kinds of inputs, all kinds of measurements and facts about poultry being processed on this line to make predictions that help make decisions that take better care of the chickens on the input and provide presumably tastier chicken tenders on the output. Now, I don't normally provide content warnings on streaming audio, but I will say we talk about the industrial processing of animal products on today's episode. So if that sounds like a bad idea to you, you should skip. Otherwise, this is a great discussion of machine learning, Kafka, Confluent, and the cloud, as per usual. Listen in. Hello and welcome to another episode of Streaming Audio. I am, again, your host, Tim Berglund, available on audio and on video. Streaming Audio now available on YouTube as well, if you want to watch us talk in addition to just listening. I'm joined in the virtual studio today by Patrick Neff. Patrick is a data scientist at a company called BAADER. Patrick, welcome to Streaming Audio.
Hello, Tim. It's great to be here.
Great to have you. Now, BAADER is not a super well-known brand in the US, I happen to know. But so tell us what BAADER does. And obviously, I always want to know, tell us about what you do and how you got to be there.
All right. Okay. So as you said, I'm Patrick, and I'm a data scientist as well as software developer for BAADER. And BAADER is a German company which is located in Lübeck. That's a city close to Hamburg in the northern part. And mainly it is a global provider for machine processing for fish and poultry. So that's what we mainly do. We create those machines. And I am working for the digitalization team, which is responsible for innovative solutions. So we develop applications based on, for instance, Kafka. And yeah, I came to BAADER in 2019 in March. At that time, I was still studying applied statistics, and I came to BAADER, or joined BAADER to do my master's thesis. And but for my master's thesis, I just took the data we had so far, which was basically just some transport data and some machine data, and try to predict the meat quality of poultry with some machine learning methods, with some success, but also some uncertainties. And yeah, back in these days, my colleagues came up with me and said, "Yeah, we are using Kafka." And actually, I just knew Kafka from my German lesson at school, because there we had to read a book from the original Franz Kafka.
Franz.
Yeah. So this was actually how my journey started at BAADER. I stayed there after my thesis, and also how my journey started with Kafka.
All right. Very cool. Very cool. So I'm glad that thesis turned into a job after graduation. That's always nice.
Thank you.
So in terms of American companies, Tyson is one that comes to mind that does large-scale processing of poultry, at least. I'll say shout out to my youngest brother. When he was 3 or 4 years old, he lived an entire, I think, year eating nothing but Tyson chicken patties, which is a whole interesting set of circumstances that could give rise to something like that. But good thing that we have this kind of food supply. You mentioned using machine learning to predict the quality of a poultry line, production line. The labeled data set there, the mind wanders into what that might look like. It strikes me that there could be unpleasant parts of the labeled data there.
Yes.
You have to know what bad chicken looks like, right?
Yeah. You have those. So during the process, we take some pictures actually of the chicken and detect some defects, which obviously have a huge impact on the quality rating finally. But when I did this analytics and had those data sets, it was You just not have one big data set where you can say, okay, now I have some expiratory variables and some dependent one and do some stuff. You have so many different ones from also so many different timestamps within the processing line that
Ah,
first it's a huge challenge to connect all these to know, okay, this information from machine A, for instance, um, doing something with the poetry is also the same poetry or the same chicken to machines later on, and for instance 20 minutes later.
okay. Can we dig into that a little bit? Do you know how that works? How do you know the identity of the chicken? Because I assume this is in various stages of processing. So at some point, it's not going to be a coherent bird anymore. It's going to be bird parts, right?
That's true. And yeah, of course we can dig into that. So what you need, especially in these food value chain network, you can say, is you need to understand the processes. That very important, because otherwise you don't know how long does the bird takes for which process, and what does machine R actually do. So that's really important. Um, but you also have some data points where you really have some measurements for one particular chicken, but also you have, for instance, the load information where you just have the information per batch, and you just know, okay, these 5,000 chickens are coming from farm A and arrived at 2 p.m. Um, let's see.
The
Um,
batch is interesting too. There,
so
that batch of chicken, because there could be properties that are common among the birds in that batch.
exactly, yeah. So
Uh,
it's huge part. It was a huge part of my thesis to figure out if the farms or the duration of the ride from the truck might have an impact on finally the quality or on some defects at the queue.
Okay. Yeah, because so I mean, backing up a step, you're doing prediction, and you're trying to predict: is it going to be tasty, and can we put it into patties to serve to preschoolers or whatever the product is, chicken tendies? Um, is it going to be a quality product that we should continue to invest in by sending it down the line because we're going to want to sell it to customers and make them happy and make their tummies full, or do we want to stop that? Right? Is there something that we can find early on in the line that says we should reject this now and not keep spending money on it? That's kind of the basic problem, right? In
Yeah,
business
but
terms.
but finding solutions for that problem would have a huge benefit. So it's not like it's not too easy to find to say, okay, now we have some results from the upstreaming processes and can say, okay, the downstreaming services need to, I don't know, reset the machines or know that there might be a batch missing. Um, Unfortunately, it's not so easy.
What are the? I mean, obviously we're but by the way, Patrick, this always happens when there's some like cool industrial process behind what we're talking about. I'm like, yeah, there's Kafka. That's cool. Tell me about chickens. Uh, so, so I will continue to ask questions about the process because I know you had to become an expert in that to get this done. I won't be able to stop myself, but we are talking about basically real-time machine learning here, or a model that is evaluated in real time. So let me try to control myself in terms of my curiosity about the plant. Um, what are the what are the inputs? You said an image before. You said there's a picture. Is most of the data that comes into your process that that you're training on and then classifying on later? Is it pictures, or are there other kinds of inputs?
No, so the pictures actually was just a tiny part. Um, Mainly, it is numerical data. So
Okay,
either really filled out by hand, um, and then produced to Kafka. For instance, as I said, the load information is all filled by the truck driver, and then you have some machine data like, for instance, temperature, pressure, what the machines actually measures, and this is also produced mostly as a numeric data.
got. So there are sensors on machines. It's doing something to the chicken, and it measures the pressure that it takes to do the thing, and that's it's too squishy or not squishy enough or whatever, and that's
Exactly.
also an input. So I'm really going to have to put a content warning on this episode because there are probably people who do not want to think about industrial meat processing, and I'm gonna let them know. So if you're at this point, you've already made it through. I always record the introduction after the episode, everybody, so you can learn how the sausage is made. Get it? Um, so if you've gotten this far, you've been warned, and you know that it's okay. So yeah, that makes sense. Machines are doing things to chicken. There are sensors. There's maybe an image and a lot of the numerical data. Um, and this is a real time problem. Can you give me a sense of how long it takes from stock coming in? This is little birdies, chickens coming in from a truck to making it to the
and
output of the process.
and are finally packed.
Yeah. How long does that take?
So up to 7 hours,
Okay,
because you first need to kill the chicken, um, and then it needs to be processed and cut, and also to chilled, and finally to cut and packed.
gotcha. And packed and then presumably frozen after that.
Yeah.
Um, yeah. Okay. So cool. Walk us through. I'm interested to know a little bit about uh, this from a machine learning perspective. I mean, there are definitely going to be people in the listening audience who are interested in that more than they're interested in the factory stuff. Not everybody is like me. So tell us about the machine learning models that you had to create, and obviously there's a Kafka interaction here. So just kind of walk us through that. What did you build, and what's it look like?
Yeah, so starting with really a basic data science project where you just had some historical data, you transferred them into the software you need to or you use to analyze, and first figuring out or trying to answer some questions. And um, for this particular prediction of the quality, I just really used the data, had them in R and Python, and did some gradient boosting and some other cool machine learning methods which I wanted to use. Um, but then here I need to distinguish somehow between having a model which is working in production in real time and is be retrained, for instance, every two weeks, and between some applications or microservices we build based on our analytics results. So talking about the later one, the later first. We discovered some answers of our questions. So one big issue is always the animal welfare. So you have the poultry, which is driving from the farm to the factory, and some chicken dies along the way because it is bad planned. There is some uncertainty because they do not know with how many birds the truck is loaded, even though that should be clear. It is not in reality, which is a huge problem. And also somehow the scheduling of the truck arrival. So they say, okay, this truck might arrive at 2 p.m. and actually it arrives at 3 p.m. And all these problems we figured out. We took the data, tried to answer some questions, those questions, and develop some solutions, and then implemented those solutions in some microservices using Kafka Streams and KSQLDB. Um, yeah,
Well, tell me more about that. So, and let me be. I want to hear what you did with KSQLDB. That's super cool. But specifically, when you say implemented those solutions, do you mean you had static set of data that was labeled? You built models. You did gradient boosting. You did engaging and interesting machine learning things, and then created a model. And you're just running that in real time, like as a KSQL UDF, or talk me through what the services looked like and what KSQLDB looked like there.
here. So we are one step before having those machine learning models, the actual models itself, running on production. So we figured out that the temperature might have an impact on the animal welfare, and so we said, okay, let's get those weather information in real time, and we implemented that as an UDF. Later on, we need to transfer it to as a Kafka Streams application because we are running KSQLDB on Confluent Cloud, and right now, unfortunately, not developed so far that you can UDFs.
At the time of this recording.
True. So that's what we mainly did. We also saw those variances in the arrival times and the planned ones, and we say, okay, we need to somehow say to the factory manager, this truck, even though it says it's arrived at 2 p.m., we need to say when it's actually arriving and that it's coming late so that you can take actions. The next step, obviously, would be to help them or help him taking actions and help to or improve the process itself, because right now it is basically just presenting some data to him. But here I'm talking just about the first step. And
Got it. That's interesting that there's the reported arrival time and there's the actual arrival time. I mean, it's like events that have timestamps. You know, they have an opinion about when they arrived, and then when they actually arrived.
true.
So that makes sense. And also it's the animal welfare aspect is interesting there, because I mean, there's an economic motivation that's going to affect process yield, right? If the animals are stressed, the end product is not going to be good. They're going to die, whatever. You know, you'll lose some percent. But also there's an ethical angle. You know, we're speaking again broadly as people who eat chicken, at least many of us. But you don't want the chickens to have a terrible life before you eat them.
Exactly.
So
Yeah.
that journey on the truck is there's more than one reason that you care about that. And so looking at things like weather, which you sort of have an objective view of, and some outside objective report on when the truck arrives versus its reported arrival time, these become inputs to your model.
Exactly. Yes. And
Okay.
based on these first steps, we're gonna develop some cooler advanced stuff, and also try to connect more of just one part of the food value chain and use it. We'd like to connect at least the entire one, but that's not possible so far. But then we would have more data points and more data at all from different sources, and could use them to gain insights.
Nice. Okay. Okay. So back to the Kafka side of things, you have. You said it ended up being a Kafka Streams application because you're running KSQLDB in the cloud, which is an extremely reasonable thing to do, but custom UDFs aren't there in the cloud yet. By the way, just a brief excursus on that. That's a super hard problem, and we don't talk about product backlogs here on streaming audio, or say that features are going to show up in a product someday. I mean, that would be foolish of a guy like me to do. So hashtag safe harbor. I'm definitely not doing that. But just thinking about that problem as a general problem, you're it's I need a sandbox to execute arbitrary code in as a part of my KSQLDB application. So you Confluent Cloud, you go be Kafka, you go be KSQLDB. Oh, except here's some code and it's fine. Run this on my messages. That's not impossible. That gets done. It's just that's the problem of custom UDFs, basically. And one would not be surprised if that was a thing that at some point fully managed KSQLDB did. But right, you had to dial it back.
Yeah.
So what? And I mean, you're kind of instructing people here as you talk on how to do this with Confluent Cloud and with sort of Kafka universe technologies. You mentioned the perfectly respectable normal Python and R tools for building your model. Then how did you operationalize that? Whatever you're able to talk about that, it became a Kafka Streams application. So I'm guessing it was some JVM language.
Yes.
But
So,
how does the model get built and run in real time?
so mainly, or for the most of our microservices, we use Kotlin.
Oh, wonderful.
Yeah, I like it too. And we just actually use Kafka Streams. So consume the data, do our modeling, or do our or add our information. So yeah, and as I said in the first step, we basically just add information together, do this, and also in a very tiny step. So we have for one product up to 6 microservices playing together and collecting all the data we need, and then just present them.
Nice. All right. Does in that final product, the model is running on Kafka Streams? Is there KSQL DB doing something still with the data? Is it still a part of the chain?
So when we have a problem, we first always try to find a solution with KSQL because it's quicker, it's simpler, and you just set up your query and let's go. So we do KSQL for instance, for some aggregations where we want to aggregate the history of some data because we want to present them how was some machine values in the last 50 minutes, 2 weeks, whatever. And exactly for that, we are using KSQL.
Nice. I like it. So what kind of results did you finally get with all this? I mean, it seems impactful. It seems like you've got a lot of data to play with. You know how to make models. Are there business outcomes that you can share that you were able to generate? Like how much better is my chicken tendy than it would have been on average?
So what I can say is that there are we could see some differences between the farms, for instance, but also how our customer uses our machines differently. So in terms of overall equipment efficiency, we can say that, okay, this customer uses or has an availability of 80%, but another one has just an availability of 65%. So what's going on between them, or what does the first customer different compared to the second one? And then you come and talk to each other and try to figure out and to optimize the processes. So there we have real business outcome. And yeah, just again, we are very at the beginning, but we receive a lot of requests and requests saying, okay, we'd like to have this feature, or could you do this and that? And so we are on that. But yeah, let's say step by step.
I love it. What's next? What do you? I mean, anytime you build a system like this, there's always something that you're mad that it doesn't do yet. What are you hoping to do next?
That's a good question. So what we are right now try to install is some pipeline where you can do data analytics automatically. So we have machines from different customers, but also different machines as well, sending different data, having other sensors. And we try to find solutions where we can analyze those data from different machines automatically, because actually we do not want to present the data because the dashboard is always cool, but what you really want to do is taking some actions if, for instance, a threshold is limited or something like that. And we want to install a pipeline which does this in an automatic way for nearly every machine that is connected to our platform, and then do not have to analyze every machine when there is a new one. This is actually a huge challenge because it's not so obvious. And that we are trying different ways out and see how we can use Kafka and, for instance, Camunda as a process engine, and to play around with those.
Nice. I have some great friends at Camunda. That's pretty cool. And previous guests on this podcast. Because I guess and I'm speaking as somebody who's completely ignorant of industrial food processing. I don't know how this works, but my guess is they'd be like, well, this stuff is really good. This needs to go to consumers, or there's a high grade, expensive, and this is still fit for human consumption, but it goes into this other kind of product. And this is still edible, but it goes to pet food or something like that. I imagine there's different ways that you get value out of that based on all these quality measurements, and being able to be smarter about those through work like yours would be pretty cool.
Yeah, it makes a lot of fun. It is really cool. So huge challenges, obviously, because as I said, tracking this through the chain is hard. And then you also have to, when you think about machine data, basically to work with this data, you need three people. You need one who engineered the machine itself, so knowing how the process actually looked like. Someone who programmed the machine, because he can say, all right, this sensor sending data of this particular part, and the data scientist who finally uses the data. And this is more often a challenging part to have all those three together and to finally come up with something everybody can agree on and everybody knows what to do next.
My guest today has been Patrick Neff. Patrick, thanks for being a part of Streaming Audio.
Thank you for being here.
And there you have it. Hey, you know what you get for listening to the end? Some free Confluent Cloud. Use the promo code 60PDCAST, that's 60PDCAST, to get an additional $60 of free Confluent Cloud usage. Be sure to activate it by December 31st, 2021, and use it within 90 days after activation. Any unused promo value after the expiration date is forfeit. And there are a limited number of codes available, so don't miss out. Anyway, as always, I hope this podcast was useful to you. If you want to discuss it or ask a question, you can always reach out to me on Twitter at @TLBerglund. That's TLBERGLUND. Or you can leave a comment on a YouTube video or reach out on Community Slack or on the community forum. There are sign-up links for those things in the show notes if you'd like to sign up. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover it, especially if it's a 5-star review, and we think that's a good thing. So, thanks for your support, and we'll see you next time.